Now let me verify. Let me go back to what we did in the beginning of class. And now let me verify that we can reproduce a simple equation system, a simple linear equation system using this equation right here. AX equals D. Let's take a very simple case. Two equations, two unknowns. A11x1 plus A12x2 equals D1. That's our first equation. Our second equation, A21x1 plus A22x2 equals D2. For this simple linear equation system, what is the coefficient matrix? What is A? What is the coefficient matrix? What is the matrix of the coefficients? Yes. How? Exactly. That is your coefficient matrix. Notice in this case, the coefficient matrix has a dimension 2 by 2. What is the vector, what is the column vector of the variables? X equals X without a subscript. Exactly. X1, X2. Notice this column vector, 2 by 1. What's the D vector? Exactly. D1, D2. Now, what happens in, let's switch to the matrix algebra form. A is a 2 by 2. Can you multiply that times the x vector? What is the dimension of the x vector? 2 by 1. And if you multiply matrix A times the x vector, the resulting matrix will have what dimension? 2 by 1. Okay. Notice these two inner numbers are the same. The outer numbers are 2 by 1. That means D is a 2 by 1, which it is. We can see directly. D is just D1, D2. Okay. Now, how do we perform the matrix multiplication? Let's just write it out. Here's A. These should be subscripts, by the way. Sometimes I get excited. I make them too high. You don't believe a person can get excited about this stuff? What happens when you multiply this matrix times this column? And how do you do it? Here's a 2 by 2 times a 2 by 1. If I ask you to multiply this times this, how do you do it? Okay, Lucy, you're starting with the first row of the coefficient matrix. And what are you doing with that first row? Exactly. And what you're doing is you're taking the first row of the lead matrix, multiplying it times the first column of the lag matrix. Of course, there's only one column in the lag matrix. So you're just multiplying this row times this column, and that's all you can do because there's only one column here. So this element you get up here is going to be, as Lucy said, A11x1 plus A12x2. And then you're done with that first row because you can't do any more, can you? Then what do you do next, Lucy? Yeah, you just multiply the second row times the first column of the lag matrix. And doing so, you get what, Lucy? Right. But that verifies, that's just what we started out with. Okay. And what is this equal? This is equal to the D vector. And what is the D vector? Just this vector right here. Okay. So this being equal to D1 is just this first equation. This being equal to this is just the second equation. Okay. So all we've done is now that we know how to do matrix multiplication, we simply verified that you can write a linear equation system in the form of AX equals D. Okay. Okay. We have just written this equation system in the form of AX equals D, and we verified that this is the same as these two equations. Okay. All right. So for now on, we'll just take this as a given, that any linear equation system can be written in this form, AX equals D. Provided that the only restriction on this is that you have to make sure A and X are conformable for matrix multiplication, that the dimensions match up. Okay. A and X and D have to have the proper dimensions. But assuming that holds, you can always write a linear equation system in this form right here.